when you look at this, just standard form for a radical, okay? When I refer to the parts of this, once again, I'll refer to this as the base, just because it's the base of an exponent. This is the power, again, terminology based on the exponent itself. That's the power of the exponent. And then one more, this was again the index. Okay. Anytime you're looking at a radical, the order that you kind of pursue writing those does not matter. So when I look at this, the nth root of a to the m is equivalent to saying the nth root of a all to the m. Doesn't matter if you apply the power or the index first. And when we get to converting between exponential form and radical form, you'll see that it doesn't matter how you approach this. So if I was giving you something where I asked you to find the square root of 25 cubed and asked you to evaluate that, do you know what 25 cubed is? No. But could you take the square root of 25 and then cube it? Yeah, the order that you do these does not matter. So what is the square root of 25? And what is 5 cubed? Okay, and so you can do that mental calculation if you just, again, apply this property that the order that you perform these can vary. Right, a couple other properties that you should be familiar with. They're very similar to what they were with exponents, and that is if you take the nth root of a times the nth root of b. So if you take two radicals with the same index, doesn't matter whether their bases are the same or different, you can, and you multiply them, you can combine that product underneath one common radical. Okay, so if you took an example like square root of 5 times the square root of 7, that's going to equal the square root, or actually let's go cube roots here. That's going to equal the cube root of, and just multiply those out, 35. Right, again, you're probably familiar with that property in terms of square roots. This same property holds true with fractions. If you take the nth root of a divided by the nth root of b, so if you take the quotient of two radicals with the same index, you can just combine those into one common radical and simplify the fraction itself. So if you're looking at, let's say, the cube root of 100 divided by the cube root of 20, all you need to do for this is combine it into one single cube root, 100 over 20. Again, the index just has to be identical between them. Reduce what you have. The factors of 10 cancel. 2 goes into 10 5 times. And so you're winding up with the cube root of 5 as your solution. Okay, one last property to be aware of, and that is if you take a radical of a radical. Okay, so if you have a radical inside another radical, you can combine those into one single radical. The base doesn't change. All that changes is the index. Indices, which is the plural of index, are multiplied. Okay, so you get m times n as your new index. Okay, so if you took the square root of the cube root of 7, instead of rooting these independently, you can just combine them into one root. The base stays the same. 3 times what's the unwritten index of a square root? 2, so 2 times 3 is. And that would be your simplified form. Okay, so again, those properties are very similar to the exponential properties that you saw already.